Welcome everybody. Thanks for joining us once again. Gil's with us today. Our good friend Gil. Let's see where he was wrong on the interwebs, shall we?
If cholesterol is really so bad, why didn't natural selection just handle it for us?
Interesting. Potential answer is later in the video, so I'll leave it until then.
This is a super common question, and I think there's two layers to it. One layer is more superficial. It's basically when people say, well, I don't believe that cholesterol poses a problem ever, because otherwise nature wouldn't have put it in our bodies. That's just a basic misunderstanding. Having cholesterol in our body is not a problem.
Thanks, Gil. Good video. You should probably stop there, because to this point, pretty factually correct. Well done. Unfortunately, though, spoiler, as I have watched this through once before, I can tell you that the wheels do start to wobble somewhat very soon. And then before you know it, there's a full cascade to complete systems failure and rubble rolling down the road. Mayhem and destruction over a wide area. So let's get there.
It's having a high cholesterol level in the blood that is a red flag.
False. That is an opinion, Gil Carvalho. It is not underpinned by science of the empirical experimental kind, the kind that actually informs us on cause and effect, risk, outcome. The only thing that alarms people about cholesterol is they are told to be alarmed by cholesterol because of some associative work which has been, well, so banged up out of shape, twisted away from anything remotely similar to a scientific discipline that it's frankly laughable, Gil. If you'd like to debate that topic with me one day live on camera, that would be welcome. We can go through the foibles and failings of the epididdly-doodly, middly-moodly-mology studies on cholesterol any time you like, my friend. Eh? Right, what's next?
Just like having high glucose in the blood is not a good thing.
Yes, but that's actually based on a sound, solid, and understood mechanism, Gil. That was an association that proved to be quite useful to us once we looked at the science underpinning it. For mechanisms, the actual important, we found it. And it's really simple and straightforward. You have normal, native, natural proteins, lipids and things in your body. And when the concentration of sugars gets too high, they have these, well, they're sharp, pointy teeth, I suppose, and they will hook onto things and leave themselves as passengers on those proteins and fat structures. They're sugar tags, and it destroys the function of those tissues over time. It's called glycation. Very simple, very straightforward mechanism. That checks out. Great. Now, if you've got a mechanism that's as clearly expressed as that and as simple as that without umpteen leaps of faith in between for cholesterol and heart disease, atherosclerosis, Gil, now would be your opportunity to produce that information, because the entire body of scientific endeavour around this hitherto has been unable to supply same. So you're up for the Nobel Prize, son, if you've got it. Spoiler, boys and girls, staff, he doesn't have it. Doesn't Gil? Sorry about that, Gil. I should let you make some progress. Off you go, son.
And yet, nature put glucose in our bodies.
Yes, but to the exact concentration required by our bodies with a homeostatic negative feedback control loop type mechanism that keeps your blood stable when you're the thing generating that sugar from non-sugar precursors, gluconeogenesis. So yes, nature put glucose in our bodies in the right amount for our genetic immediate history of the last 4.5 million years. Nature didn't put most fruits and vegetables available to human beings in the food supply. Most of those are human inventions put there by people and endorphins.
Same with high sodium or high potassium in the blood.
Yeah, but we've got mechanisms to filter that out if it gets too high. It happens in the kidneys. I thought you were a medical doctor, Gil, as well as a PhD holder. Why don't you understand that, apparently?
Most parameters have a physiological range,
yes.
And if they're too high, they can cause problems.
Absolutely. Anything and too much of it will kill you, probably. Oxygen included will do that. Oxidizes all your tissues. It destroys you. Water, too much water, well, that can kill you. Yeah, you bet. But, I mean, really, what you're trying to assert here, Gil, without providing any evidence to the effect of is that it is your belief that cholesterol is probably actually a causal agent in atherosclerosis heart disease. And unfortunately, that's an opinion. And it's an opinion that many sensible and well-trained scientists, including myself, don't share with you. That's why the debate continues, because the evidence for what you're saying is not in hand. It's still a theological viewpoint.
So that's more straightforward. Now, a more sophisticated version of that question is, if high cholesterol is a problem or an indicator of problems.
Not the same thing, are they? At all.
Why didn't evolution just come up with a solution for that?
But it kind of did. The level of cholesterol present in a person at any given time is almost entirely under the control of that person's genes. Those genes having the capacity to react to the environment in which those genes are placed by that person at that time. So there you go. It's quite a good solution. It's been working for us for, probably around about 13.8 billion years or so. If you believe that's where life began, at around about that stage, almost immediately upon the moment of creation. We could debate when life started, if you like, but that's not really the point of today's video.
Like capping our cholesterol levels, for example,
Well, it kind of does. There is a physiological range within which otherwise functioning genetically human beings will express. It's a Bayesian distribution. That's what we'd expect, pretty much. But it seems that there is a cap, in effect.
Not allowing them to go above.
There are people with genetic issues, meaning that they actually can't absorb any of the lipoproteins or lock on to any of the lipoproteins so as to absorb their contents. Thus, the levels in their blood get well above, like deviations above a normal human being. That's not who we're talking about today. We're talking about the vast majority of humans. Okay? We can talk about the special populations in another video if you want to, Gil, or on another day if you want to discuss that population with me in a debate-style discussion. That'll be welcome as well.
A certain range, or coming up with some protection, some mechanism whereby even if they do rise, the cholesterol level rises, we're somehow immune to that and we don't have any...
Okay, somehow immune leaves us, or leads us, those of us who are leadable, to a conclusion that there is a problem with cholesterol, because otherwise immunity wouldn't be a word that would come into this situation. Why do you need to be immune to something that's not a problem? So what Gil is doing here is framing, or attempting to frame the viewer's mind to take his viewpoint that cholesterol is causal artifact of atherosclerosis development, which there's still no evidence for, Gil. But we'll get to that when I stop waffling.
Issues. And of course, the same question would apply to glucose and potassium and all these other things. Why didn't we just evolve protective mechanisms against all that? So,
well, we did.
There's a few possibilities. One possibility is that maybe our ancestors never had high glucose or high cholesterol.
That's almost certain that they never... Well, our ancestors in our species, Homo sapiens, for the last 11,000 years we've eaten an amount of carbohydrate-laden stuff as a species, but prior to that, no. Almost entirely, nutrition-wise, it was the muscle meats, mostly, and associated fats of large ruminant animals, it seems. So our ancestors would have had an appropriate level of lipoprotein carrier for the amount of cholesterol being acquired by that human's body at that time. And I don't suspect that control mechanism, that tight control of that physiological thing by the virtue of the actions of the genes, I don't think that's changed. We still have that. So I suggest that cholesterol levels are not probably meaningfully different, but we could guesstimate that until the cows come home, couldn't we, Gil? Because I don't think either one of us could really point to any evidence that his posit is correct. So I think the cholesterol levels are not remarkable now. I think they're exactly what they probably were then. Prove me wrong. That'd be cool if you can.
or had it so rarely that there was no evolutionary pressure to come up with a solution. Or maybe they didn't live long enough for it to be a problem.
All right, so antagonistic pleiotropy. All right, good. We'll get to that in a minute.
Since these are chronic diseases, type 2 diabetes, cardiovascular disease, that normally take a while to cause serious problems and typically hit later in life. Yet another possibility is that the same trait provided some advantages and some disadvantages, and the net effect was worth it for our ancestors. So this is the idea of antagonistic pleiotropy that we've talked about in previous videos several times. And it's a fancy name, it's a big word, but all it means is that the same factor has multiple effects in different directions.
Well, most factors probably do, Gil.
Some good, some bad. The classical example of antagonistic pleiotropy is sickle cell. It's a genetic condition where your red blood cells become flattened in the shape of a sickle, and it raises risk of death in children. So it tends to be weeded out.
With a mechanism that we understand, an inability to carry sufficient oxygen to the tissues. Unlike a plausible mechanism for the development of atherosclerosis under the influence of cholesterol somehow. Do you see how that's different?
Evolutionarily. Except in some regions, like for example, some parts of Africa, where it persists. And it's even common. So why would that be?
Because it provides some level of immunity to malaria, is my understanding.
Because that same trait also provides an advantage. People who are carriers of the sickle cell gene are more resistant to malaria. They're less likely to die or to have serious complications from the infection. So in areas where malaria is endemic, where it's common, carrying the sickle cell gene provides an advantage.
Right, so there are both positive and negative selection pressures on that exact same genetic change leading to the change in the formation, the shape of the red blood cells. That's antagonistic pleiotropy. Fantastic. But that doesn't apply here because there is no identified, agreed upon, and obvious mechanism by which cholesterol could possibly be a causal contributor to atherosclerosis heart disease, and neither is there any evidence of any cause and effect relationship there. It's a construct, it's an idea, it's an empty vessel. It's a box being put on a graph for now until we can flesh out what's actually in that box. It's a guess, it's a hypothesis. It's not established science, unlike the sickle cell trait thing, which absolutely is.
That offsets the harm. Whereas in other areas where there's no malaria, so in most of the world, it's clearly a net negative to carry that gene, and so it gets weeded out. The key take-home message here is that different environments can make the same trait be adaptive or maladaptive. There's a
Yes, we get it.
very interesting paper by some cardiovascular researchers.
Rather than just writing reference to there, I mean, we could go and have a look, but why don't you discuss the thing a bit? If this is a paper worth mentioning at all, then let's have a look at it. And we'll tell you what's wrong with it, because there will probably be lots of things.
That argues that something similar might have happened to...
Might. There it is. Okay, maybe not too. That's how these things get published. Gil, they have to put the word in there because, well, precisely because, they are unable to say, here is a fact that we have now established using experimental science. So this is an idea, an opinion.
Cholesterol. That our ancestors lived in a harsher environment where food and calories were much harder to come by, so genes that helped them store energy might have been advantageous.
Right, thrifty genes, of course. The same is true of the Pacific population, who set out, it seems, from somewhere around about the southern area of Taiwan about 1,500 years ago, it seems, on canoes to find the Pacific nations and populate them. It would make sense. There would be a positive selection pressure for the survivors of such a journey to be those who have thrifty genes. Hence, at least in the Pacific population, there's also a propensity to store more body fat, as well as to be larger, more robust, more muscular, sure, and to be good at sports and stuff. So really, this is just a seminar about how genetic drift occurs as a function of positive and negative selection pressures, which we understand, Gil. This video is supposed to be clearing up any misconceptions that we might have in our minds about this supposed causal relationship between cholesterol, or any of the lipoproteins, or any subfraction of the lipoproteins, and atherosclerosis heart disease, the evidence for which is still absent. That's probably why all this waffle, all this subterfuge and segue away from the actual facts at hand. Let's have some of those facts, Gil.
These authors call them thrifty genes, basically genes that help us save and store energy and prevent squandering it. So their idea was that storing fat and having more of these fat transporting vehicles in our bloodstream, like lipoproteins, may have been protective. Because the priority...
Well, of course it would have been. The ability to carry fat around our bodies and thus be able to store it and release it, take it somewhere else and use it for energy, might have been handy if there was limited energy to be had. Yes.
To have nutrients and energy stored up in the system to avoid malnutrition and starvation. And everything else was secondary, like longevity or what happened 30 years down the line. So they hypothesized that genes that increased the number of VLDLs in our bloodstream, VLDLs are these large lipoproteins that carry mostly triglycerides, which are a form of fat, may have been adaptive in this harsh and calorie-poor environment.
Sure.
Now, VLDLs, as they progressively deliver their triglyceride cargo to tissues around the body, get increasingly smaller and eventually become IDLs and finally LDLs.
Oh, right. And through this process of doing nothing really other than offloading the cargo to the cells that require that, those lipoproteins, or what remains in those lipoproteins by way of their cargo at that time, is now suddenly, magically, pathogenic. So natural design is so incredibly precise, self-correcting, etc., that it can build a human body and do all the things it can do. And yet, it's so stupid, Gil, as to have a genetic instruction for a protein, a lipoprotein in this case, which is going to do us harm. Why would your body be designed that way? It simply wouldn't. It does not make any sense. And unless you provide us with a mechanism pretty damn skippy, I think we're just going to have to say, well, it looks like your hypothesis remains a hypothesis, an unproven idea, and one that's pretty damn stupid, actually, from its very core foundations.
So the idea is that these lipoproteins helped distribute energy throughout the body.
No, fat and other water-insoluble substances. Mostly fat at the beginning of the process, as you outlined there, Gil, leaving the other things behind for reception later to cells that will directly bind to an LDL to get those goodies out of what's remaining, because by that stage it's largely cholesterol.
Which was advantageous during times of famine and energetic scarcity. But as nutrients became more abundant and ubiquitous, this same capacity to store fat and to have all these fat vehicles, these lipoproteins floating around in our bloodstream, became maladaptive.
Yeah, but in what way? I mean, the identified pathway there by way of maladaptation for that is a carriage of body fat, a homeostatic set point on that, which is too high, perhaps, whereby many of the individuals who are in that genetic group will suffer the sequelae of obesity-related issues, especially in today's society, which is vastly less active and where energy is much more available. Yes, but so what? How does any of that relate to heart disease, other than the known impact on heart disease prevalence, it seems, with obesity itself? A non-cholesterol-based mechanism.
Because nowadays, we're not at risk of starving anymore, most of us Westerners. But we live pretty long lives, and these lipoproteins, when they're in high number in our bloodstream, can get stuck in the artery walls and can cause plaque to gradually accrue, to grow over the years.
Okay, you missed quite a few steps there, Gilly. You know how I was talking about a mechanism that doesn't have all these leaps of faith? You've just skipped from A to Z in one step. These lipoproteins, when they're in high concentration, can get stuck in the walls, you said. That's not a mechanism. That's a loose description. Tell us what has gone on exactly. Why is this occurring? Is this occurring? What you've shown us here is a comical, really, pseudo-representation of the physiology at hand, a laughably ill-detailed little vox pop thingy here, so that clowns like you can say LDL in high concentration gets stuck in the walls and causes these plaques here. No, Gil. This is utter rubbish. This is not the mechanism of atherosclerotic development. Not remotely. It's not even close. That's actually laughable by anybody who actually understands the physiology and pathophysiology here, as I do. Wow. Show us your little diagram though, Gilly.
And can eventually lead to heart attacks and strokes. And this has become...
well, hang on a minute. Again, with this, what mechanism are we talking about here? What causes this thing that's being shown on the screen here to happen? What exactly? What is in that? I presume that's supposed to be the lesion. What's in there? What are its constituents? No? A little cartoon that you can enjoy so that Gil can give you his opinion again, so that you can just accept his opinion as being somehow informed by science. It isn't.
Our number one killer. Regardless of whether the details of their theory are right or wrong, whether it pans out or not, the general concept is that something that arose as a survival tool can sometimes become a handicap if the environment changes.
Great. So tell us how that is so with cholesterol then, because you're now 3/4 of the way through your film, Gil, and you've provided not one single scrap of evidence to support this idea. None at all. You've given us a bunch of opinions and theories. You've outlined some known mechanisms of the development of genes in the universe, genetic drift, but that's it. You haven't connected heart disease, atherosclerosis with cholesterol in any way.
And vice versa, right? A weakness can also become a strength in the different environment, like we saw with the sickle cells. So it's just not as simple as, well, if X was bad, evolution would handle it.
Well, evolution does handle it, Gil. Evolution handles everything, unless you're a believer in luck, which I'm not really.
Evolution doesn't plan ahead, and it has no...
It has no need to do so. It's reactive, Gil.
Knowing if and when and how the environment will change. In fact, even now that our propensity for heart attacks and strokes has clearly become a major problem and a handicap.
Yeah, absolutely, Gil, but you haven't provided us with the reason why that is so. Why have we got so much worse in terms of our heart health in the last even few generations? It's got worse and worse and worse. Why? Cholesterol is not the answer.
There's still no guarantee that evolution is going to do anything about it. As the authors explain, natural selection is ill-equipped to control hypercholesterolemia's prevalence. Today,
this assumes that there is such a thing as this hypercholesterolemia. That is a label appended on the basis of a decision based in opinion. One's cholesterol level in one's blood is what it is. And it is that precisely because the genes have made that so. Hypercholesterolemia. Unless you're one of these 1 in a million individuals with a complete genetic knockout, meaning you are unable to bind LDL, and ergo the concentrations of these lipoproteins and lipids and things build up in your blood rapidly to a point vastly distinct from the general population. So those people aside for this video, your blood cholesterol is what it is because your genes have made that so, knowing exactly what they are doing.
Today, or in any era, because it's adverse manifestations.
Adverse manifestations, such as what? Let's go back again and have a look at the mechanism description that was provided by Gil in this video, or indeed anywhere else in the literature, in fact. Okay? This is my whole point. This is an idea without a mechanism even. Most people I talk to on this topic, when I ask them a simple question like, oh, that's interesting, can you outline for us what the percentage makeup of your average atherosclerotic lesion is, that they're unable to do that, and yet they still think themselves expert enough to profess in this area. Oh, so cholesterol's clogging our arteries, is it? All right. No.
Generally occur beyond peak reproductive years. In other words, Because the bulk of the heart attacks and the strokes.
Yeah, but they're not down to cholesterol, Gil. So this is an irrelevant line of logic. Yes, antagonistic pleiotropy may well be at play, but not because cholesterol causes heart disease. It still doesn't.
And the cardiovascular death happened in our 60s and 70s and beyond. And because by that time, we've done most, if not all, of our reproducing, it might not be too relevant, evolution-wise, whether we suffer or die at that later stage in life. Point here is we have to be wary of these one-liners on social media that seem to make sense at first glance.
Or even silly cartoon-style animations that don't remotely represent what's physiologically occurring in atherosclerotic lesion formation. That's the other thing we should be aware of. We also should be aware of people throwing around X number of qualifications who don't actually have any clinical experience in any field, be that clinical practice and or research. We should probably also be aware of people who are way, way too overconfident in their own knowledge and skill set. There are many things people should be aware of, yes. Buyer beware.
Things are a lot more layered than that. And there's many reasons why a trait might persist evolutionarily. From it providing an advantage in one environment but not another, to it just not.
Now you're just repeating yourself, Gil. This is your summary now, obviously, is it? Looks like you're starting to summarise. You've provided us with nothing. You've provided us with an idea, which is irrelevant because the base premise of this entire video that we were starting from was that in your mind, LDL is causal in heart disease, when it isn't. So the whole thing was pointless.
Not being evolutionarily very relevant, even if it's a huge deal for us. If you have an interest in these questions of nutrition and evolution and health, we have a full interview with a paleoanthropology professor going over everything that's known about what our ancestors ate, and we'll put it right here. And we have a second video on nutrition and evolution where we talk about these principles of antagonistic pleiotropy and all that fancy wording.
Is there as much guesswork in that stuff as there has been in this one, Gil? Do you provide any mechanisms of any kind or underpinning experimental work of any kind, or do you just espouse an opinion?
All right, and we'll put it right here, so check those out. Let me know your questions below. I'll see you next time. Bye-bye.
Right, so nothing there of any value or utility, Gil, or even anything that's factually correct in any way. Just noise. Adding noise doesn't help. We need people adding information, facts, re-teaching ourselves the scientific discipline, the scientific method, relearning stuff we've forgotten in a generation, clearly. That's what we ought to be doing. Those that want to come on that journey with me, stick around this channel. Join me next time when someone else will be wrong on the interwebs, because it doesn't look like slowing down anytime soon. See you then.